Hey physics students, it is Miss Wenslaff here, and welcome to my newest flipped lessons that I am going to be doing for AP Physics 1. Today is motion part 1. We are going to be focusing on motion vocab and graphing motion. Let's get started. Our first vocab word that we talk about in physics is scalars and vectors. Scalars are simply just a number plus a unit. Where would I see this in real life? 30 miles per hour, 10 miles. But then I have my vectors. Vectors are really the base of physics. This is something with direction. Okay, and when we define direction in physics, we can do it a ton of different ways. So let's say I have 30 miles per hour. So I still have a number plus a unit. Now I have a direction. So I could say north, or I could say 10 miles, 30 degrees northeast, or I could say 10 miles and I could put an up arrow. All of these are examples of vectors. I just want to reiterate that vectors are most of what we use in physics. So as we go through this vocab today and in the future, I'll be talking about whether something is a vector or something is a scalar. Distance and displacement. Well, to start, distance is a scalar, no direction. Displacement is a vector, so I have to have direction. That is the number one difference between distance and displacement. Let's look at the real definitions though. This red line right here, this is showing me my path. So this little boy in this bicycle, he went to his house, then he went to the tree, okay? So my distance, I always like to say that this is the path that I took. However, my displacement is my shortest distance from start to finish. Now, you may be saying in a real situation, how is this actually useful? Well, it gives us direction, and that's what we want. In this example, the boy's displacement was 5 meters. What am I missing here? I'm missing a direction. So I'm just going to make up one right now. Let's say this is 30 degrees and this is northeast. Okay, so I always have a distance and then a direction with it. One of my favorite examples is thinking about a start and end line. Okay. Let's say I am going around a track and I run and I run and I run and I come back to the start. And let's say I went a distance of 400 meters. Now I'm starting and ending at the same spot. I have to think of myself, what would be my displacement? If I start and end the same place, my displacement is equal to 0, okay? One of these kind of weird parts of physics, but important for us to know. One of my tips for this is that displacement is always equal to or less than the distance. Let's learn some more vocab. Speed and velocity. Some of the most misused words in life and physics. Speed is a scalar and velocity is a vector. Pretty easy to memorize because they start with the same letters. Speed, pretty simply, is my distance over a period of time. Let's say that maybe I drive 100 miles in 2 hours. This would make my speed 50 miles per hour. I do not have any direction in here. My velocity, though, has to have direction. I'm going to use V to represent velocity. And this is my displacement over time. I'm going to show you a better way to write this that is more AP Physics style, and that's delta x over t. Let's think back to chemistry. What does delta stand for? That is change. When you get into kinematics, we'll talk a little bit more about how do we figure out that change, okay? Velocity, how would this look different? Well, in the same scenario, let's say that I went 100 miles let's say west, still going over 2 hours. Now my answer is 50 miles per hour with west. Now let's look at this delta x, okay? Anytime I have this delta, and we're going to see this again, it's a change. This is going from my final position minus my initial position. We're often going to see this x initial as 0, but not always. We are going to see this again in the next slide. Our last vocab word for today is acceleration. And acceleration is also a vector. Acceleration is our change in velocity over time. Okay, you'll see this over time is really important to us when we talk about kinematics. My equation, I have acceleration equals the change in velocity over time. Very similar to what I just described, my change is my final velocity minus my initial velocity over t. You may be saying to yourself, do I need to memorize this? Nope. This is on our equation sheet. Don't worry, we'll get to that in our next flipped lesson. When we're talking about acceleration, this is any time the velocity is changing, okay? Let's say my initial velocity is 4 meters per second and my final velocity is 4 meters per second. And let's say that happens over 5 seconds. What would my acceleration be? I have 4 meters per second minus 4 meters per second over 5 seconds. That gives me 0, okay? Now, basics here. I talked a little bit about units, but that is something in the next flipped lesson that I'm going to get to. One of the most essential part of physics is graphing motion. I could jump into my equations if I wanted to, or units, or any of those fun things, but I don't really want to do that because the AP test loves graphs, and it is a way to show if you truly understand something. Now, when we have graphs, we always have an origin, okay? And origins typically are at 0, 0. Let's look at what graphing motion would look like, okay? Let's say that I start -4 meters from the origin, and it takes me 3 seconds to get to my 0 point. Then let's say from 3 to 5 seconds, I stay there, and then from 5 to 7 seconds, I jump up to 4. And then at 10, I move back to my origin. So in this situation, I'm walking towards the origin, through the origin, and back, okay? What would this look like in more of a visual way? Okay, I'm gonna put my origin here at 0. My starting place is all the way back here, and that is at -4. Then I'm walking to my origin and I kind of stay there for a while. Then I walk forward a bit and then I come back to my origin. If I was actually doing this in real life, this is what it would look like, and then I have my graph. There are a lot of pieces to this puzzle. And one of the things that I want to note and have you think about is, what does this slope mean? Okay, let's think about slope. Slope is my rise over my run, okay? If I look at this graph, my rise is equal to my distance and my run is equal to time. Stop a minute and look back in your notes. What equation did I present to you that is also distance over time? Guess what? It's speed. Super cool. The slope of a distance versus time graph actually shows me my speed. One of the coolest parts of physics right here. This is where I'm going to end this lesson. I have a follow-up lesson that goes through kinematic equations. Make sure that you took notes during this and you are ready for class where we will talk about this more.